Assalamualaikum warahmatullahi wabarakatuh. So in part number 3, first I will explain about the property tables to obtain the data for saturated liquid and also saturated vapor states. Okay, so this is TV diagram and also PV diagram to show the different region of the pure substance. So for saturated liquid and also saturated vapor states, if you refer to the TV and also PV diagrams, will involve the saturated temperature and also saturated pressure. Okay, so the point of saturated liquid and also saturated vapor states will involve a horizontal line for the constant pressure and also constant temperature. Okay, constant pressure for TV diagram and constant temperature for PV diagram. Okay, so this is the saturated liquid states, where at this point we have 100% liquid. Okay, so in terms of symbol that we use to describe the saturated liquid state, we will use F symbol, okay, small letter F. So whatever properties that involve with saturated liquid state, so we will use subscribe F symbol. Okay, for example, for specific volume we will use VF, for enthalpy HF, internal energy UF, and for the entropy we will use SF, and so on. Okay, same goes to PV diagram. And then we have the second point, or the second state, referred to saturated vapor state as shown in the figures, where at this point, in terms of phase, at the point the phase is 100% vapor, okay, as shown in the figures. And the symbol that we use to describe the saturated vapor state is G, small letter G. And whatever properties that involve with saturated vapor state, we will use subscribe G. For example, for volume we use VG, enthalpy HG, internal energy UG, and the last one for the entropy we will use SG. Okay, same goes to PV diagram. So in order to obtain the data for saturated liquid and also saturated vapor states, we need to use saturated table. Okay, for this case, for example, let's say we want to obtain the data for water, so we need to use a saturated water table. So there are two types of table for saturated water, or saturated tables. First, saturated table based on pressure, okay, as shown in the slide. And the second one is the saturated table based on temperature. So both table actually in terms of data value is the same, but the difference is only the title at the first column. Okay, for the saturated table based on pressure, the first column in terms of data is the column for pressure. However, the saturated table based on temperature, the first column will be the temperature data. Okay, so in the table we will have numbers of properties, so we can determine the data for pressure, temperature, specific volume, internal energy, enthalpy, and also entropy. So for example, let's say we want to determine the data for pressure equal to 1.0 kilopascal. Let's say this one, the example for water. Let's say so we need to refer to saturated water table based on pressure. So if you use this table, we will get all the data directly from the table. Okay, so we need to find the value for P, pressure equal to 1 kilopascal in the table. So from the table directly we can obtain saturated temperature, which is equal to 6.98 degrees Celsius, and also we will get the value for what I call the specific volume at saturated liquid point and also saturated vapor point, VF, VG, and we can calculate VFG, which is VFG equal to VG minus VF. And also you can obtain the data for the internal energy, enthalpy, and also entropy. Okay, So for the data for saturated liquid, so you need to refer to the value of VF, UF, HF, and also SF. However, the data for saturated vapor states, you need to refer to VG, UG, HG, and also SG. However, if you decide to get the same data, but now by using the temperature table, so now you can obtain the data directly from the table. So you need to make an interpolation in order to obtain the data. Okay. So now, if you look saturated water table based on temperature, so pressure 1.0 kilopascal. Actually, if you look in the table, is in between 0.8721 and also 1.2276. Okay. So for example, if you want to obtain the value of temperature, you need to make interpolation between the pressure data and also the temperature data. And then if you want to determine the specific volume data, so you need to make interpolation between pressure data and also specific volume data, and so on. Okay. Okay, for this case, let's say we want to determine the saturated temperature by using saturated water temperature table. Okay, so we have this data. So in order to make interpolation, the basic concept of interpolation actually is we need to use the gradient concept. Let's say the data that we already known is data for pressure represented by X. Okay, the lower value data X1, the higher value data for pressure X2, and we want to determine Y, which is represent the T saturated value, and Y1 represent the lower value of temperature, and Y2 refer to the higher value of temperature. So we need to use all this data in order to make interpolation to obtain the exact value for T saturated at pressure equal to 1 kilopascal. So the basic concept of the interpolation is the gradient equation. Let's say we have a line with 3 point or 3 coordinate. So we have xy coordinate, x1 y1 coordinate, and also x2 y2 coordinate. So this coordinate represent the data that we already mentioned before. Okay, the data for the pressure and also the data for the temperature. So the basic concept is the gradient for xy and also x1 y1 is equal to the gradient between the coordinate of x2 y2 and also x1 y1. Okay, so this gradient equal to the second gradient. So by using this concept, we can make interpolation. So we have y minus y1 divided by x minus x1 equal to y2 minus y1 divided by x2 minus x1. So in order to determine the T saturated value for pressure 1.0 kilopascal, which is the value of y, so we need to rearrange the equation. So you'll get y equal to y2 minus y1 divided by x2 minus x1 multiplied by x minus x1 plus y1. So in order to use this interpolation, so you need to make sure that your arrangement of data must be correct, and replace y with t and whatever data that we obtain from the table. So from the interpolation method calculation, so you get T saturated for the 1 kilopascal equal to 6.799 degrees Celsius. So if you compare with the direct method that we obtain from the saturated water pressure table, so the value will be slightly different but still acceptable. Okay, so that's how we can determine what I call the data for saturated liquid and also saturated vapor by using the properties table. Okay, now we look at example 3.1. A rigid tank contains 50 kg of saturated liquid water. Determine the pressure in the tank and the volume of the tank if the saturated liquid water temperature is at A 90 degrees Celsius and B 93 degrees Celsius. So if you refer to the example question, so mass already given, the phase of the water already given, which is saturated liquid, and we need to determine the pressure in the tank and also the volume of the tank if the temperature of the liquid water, which is referred to the saturated temperature at 90 degrees Celsius and also 93 degrees Celsius. First, try to draw simple schematic diagram in order to get a clear picture. So just draw simple schematic diagram and put whatever data given in the question. Okay, as shown in this slide. So we have saturated liquid water, and the mass is 50 kg. So we do not know the pressure of P value and also the volume of the saturated liquid. Okay, so we can describe what I call the condition of the example 3.1 by using TV diagram. Okay, now for question A, the saturated temperature for the saturated liquid water is 90 degrees Celsius. So automatically for saturated liquid states the temperature given or the pressure given actually refer to the for the temperature refer to the saturated temperature. So if the value of pressure also given, so that value refer to the saturated pressure value. Okay, for this case, the temperature given actually refer to T saturated, where T saturated equal to 90 degrees Celsius, and the phase also already given, which is saturated liquid, and mass equal to 50 kg. Let's say we have unknown constant pressure line with saturated temperature of 90, and we know that the phase is saturated liquid, so we will use symbol F symbol as shown in the TV diagram. Okay, so in terms of specific volume, we will have VF because our state actually is at saturated liquid state. Okay, we need to know the pressure and also the volume at this condition. Okay, so the related equation will be, because we need to determine the volume, so V volume equal to mass multiplied by specific volume. So for this case, the specific volume will refer to VF, and P equal to P saturated at 90 degrees Celsius. So now, because we already know the phase is saturated liquid, so we need to refer to the saturated table. So now the substance is water, so we need to refer to saturated water table based on temperature. So we can choose based on temperature or based on pressure, but we need to choose the what I call the easiest one. So for this case, we can get direct data from the saturated water table based on temperature. Okay, so from the saturated water table based on temperature table, so we can obtain directly at 90 degrees Celsius. So we can get the saturated liquid pressure P at 70.14 kilopascal. Okay, in terms of how to write the symbol, so the saturated liquid pressure will be P saturated at 90 degrees Celsius equal to 70.14 kilopascal. And then the specific volume from the table, we will obtain that V small letter equal to VF at 90 degrees Celsius, which is equal to 0.001036 meter cubic per kg, where the value we can obtain directly from the table. Okay, so in order to obtain the volume, okay, so you need to make sure that you need to identify the difference between the specific volume and also the volume. So the specific volume, the unit will be meter cubic per kg, but for the volume, the unit will be meter cubic. Okay, so V equal to M mass multiplied by VF at 90 degrees Celsius, which is equal to 50 multiplied by 0.001036. So we will get the total volume at that state is equal to 0.0518 meter cubic. Okay, so we already answer both, where we already determine the pressure of in the tank and also the volume of the saturated liquid at 90 degrees Celsius. Okay, now question B, by using different saturated temperature, where now our T saturated will be 93 degrees Celsius. So we'll use the same method, where we have the data given 50 kilogram phase saturated liquid and T saturated now equal to 93 degrees Celsius. Okay, so we have another constant pressure if you refer to the PV diagram. So we have new point for saturated liquid that represented by blue color F symbol, and now our T saturated equal to 93. So we need to know P value and also VF. So by referring to the saturated water table based on temperature, so now because the value is in between, in terms of temperature, in between 90 to 95, so we need to make interpolation. Although we refer to the same saturated water temperature table. Okay, so based on the table, so 93 degrees Celsius is in between 90 to 95 degrees Celsius. And now we can determine the pressure of P saturated at 93 degrees Celsius by using interpolation, similar to VF at 93 degrees Celsius. Okay, so saturated liquid pressure by referring to the interpolation method. So P saturated at 93 degrees Celsius minus 70.14 divided by 93 minus 90 equal to 84.55 minus 70.14 divided by 95 minus 90. So rearrange the equation, so we'll get the value for P saturated at 93 degrees Celsius, which is equal to 78.786 kilopascal. Okay, so we already get the saturated pressure for temperature at 93 degrees Celsius. Next, determine the specific volume also by using interpolation. So we have VF at 93 minus 0.001036 divided by 93 minus 90 equal to 0.001040 minus 0.001036 divided by 95 minus 90. So all this data actually we can obtain from the saturated water table based on temperature. Okay, so we'll get VF equal to 93 degrees Celsius. VF at 93 degrees Celsius equal to 0.001038 meter cubic per kg. Okay, so from VF value we can determine the volume for question B. So the volume equal to MVF at 93 degrees Celsius equal to 50 multiplied by 0.001038 meter cubic per kg. So we'll get the final answer for the volume will be 0.05192 meter cubics. Okay, that's how we that's how the solution for the example 3.1 for the saturated liquid water. Okay, example 3.2. A piston cylinder device contains 0.06 meter cubic of saturated water vapor. Determine the temperature and the mass of the vapor inside the cylinder if the saturated vapor pressure is at A 350 kilopascal and B 370 kilopascal. Okay, so the system involves piston cylinder device, and the volume, total volume may be 0.06 meter cubic, and the phase of the water is saturated vapor. So now you need to determine the temperature and also the mass. So the temperature actually refers to the saturated temperature because now the phase is saturated water vapor. Okay, so now try to draw a simple schematic diagram. Put whatever data given as shown in the slide. Okay, and also we can use TV diagram to describe the process. Okay, question A, pressure equal to 350 kilopascal. Okay, so this we refer to the first constant pressure line where P equal to 350 kilopascal, and we know that the total volume of the saturated water vapor inside the cylinder is 0.06 meter cubic, and the phase is saturated vapor, and P given actually equal to P saturated equal to 350 kilopascal. Okay, and the point that referred on the TV diagram is point G, okay, which is referred to the saturated vapor states. Okay, so whatever properties refer to that point, refer to the, for example, for specific volume, refer to the Vg value, and so on. Okay, related equation, because we want to determine the mass. So original equation is V equal to M multiplied by specific volume. So we just rearrange the equation. Okay, so we'll get the mass equal to V, the volume, divided by specific volume at saturated vapor condition, Vg. And T is referred to the T saturated at 350 kilopascal. Okay, so now refer to the saturated water table based on the pressure. So by using the pressure tables, we can get the data directly from the table. No need to make interpolation. Okay, this is the data for saturated water table based on pressure. Okay, so if we refer to the table at 350 degrees Celsius, the saturated vapor temperature will be at 138.88 degrees Celsius. So the data actually directly from the table. We can get directly from the table. Okay, now about the specific volume. The specific volume V equal to Vg at 350 kilopascal. By referring to the table, the value is 0.5243 meter cubic per kg. Okay, manipulate the formula for the mass, so we can obtain the total mass for the saturated water vapor for this example. So M equal to V divided by total volume divided by the volume for the saturated water vapor, which is equal to 0.06 divided by 0.5243. So we'll get mass equal to 0.1144 kilogram. Okay, so we'll answer the temperature and also the mass of the vapor inside the cylinder. Now question B, we change the value of pressure, where now the pressure is 370 kilopascal. So we need to refer to the other constant pressure line in the TV diagram, where we have P equal to 370 kilopascal. Okay, so now our new P saturated will be 370 kilopascal, and the phase still saturated vapor, and the total volume also same, which is equal to 0.06 meter cubic. Okay, so now the point we refer to the blue color G at the TV diagram, on the TV diagram, and also the specific volume also we refer to the value of Vg. Okay, so by referring to the saturated water table based on pressure, so now because the value of 370 kilopascal, if you refer to the saturated water table based on pressure, the value is in between 350 and also 375, which means in order to obtain the data for that pressure, we need to make interpolation. Okay, so first, in terms of temperature, the temperature will refer to the T saturated at 370 kilopascal. So we need to make interpolation based on the table. Okay, so the saturated temperature at 370 kilopascal will be in between 138.88 and also 141.32. Okay, so we need to make interpolation between the pressure data and also the temperature data. Similar goes to Vg. Okay. Okay, saturated water temperature, use the interpolation formula. So we have T saturated at 70 kilopascal minus 138.88 divided by 370 minus 350 equal to 141.32 minus 138.88 divided by 375 minus 350. Okay, so rearrange the equation. So we'll get the value for T saturated at 370 kilopascal, which equal to 140.83 degrees Celsius. Okay, so now by using the same method of interpolation, so we need to determine the specific volume at saturated vapor, which is referred to the Vg value. So Vg at 370 kilopascal minus 0.5243 divided by 370 minus 350 equal to 0.4914 minus 0.5243 divided by 375 minus 350. So rearrange the equation, so you'll get the equation for Vg at 370 kilopascal, and the value is equal to 0.49798 meter cubic per kg. Okay, so now substitute into the mass equation. So M equal to total volume divided by Vg at 370 kilopascal. Okay, substitute all the value that we obtained. So we'll get the final answer for the mass of the saturated water vapor for pressure at 370 kilopascal equal to 0.1205 kilogram. Okay, that's how we solve the problem involved with saturated water vapor by using the properties table. Okay, now we have example 3.3. The third example I call related to the saturated liquid water and also the saturated saturated water vapor. Okay, so for example number 3.3, the question will be slightly different because the question will involve two different states. Okay, a mass of 200 gram of saturated liquid water is completely vaporized at a constant pressure at 100 kilopascal. So first determine A, the volume change, delta V, and B, the amount of energy transfer to the water. So we need to know how much amount of energy transfer from state number 1 to state number 2. Okay, so in terms of data given, mass already given for saturated liquid water, pressure, total pressure already given, 100 kilopascal. Okay, so try to describe by using the simple schematic diagram and also the TV diagram if possible. So this is TV diagram, and in terms of schematic diagram, state number 1 is saturated liquid saturated liquid water, which is 100% liquid, and we add heat in order to vaporize the saturated liquid. Okay, so the state number 1 will be at saturated liquid as shown in the TV diagram, state number 1. So we have the property involved with saturated liquid, and then due to the heat addition, so the liquid will vaporize. Okay, so the liquid water will experience the vaporization. So the state will reach up to state number 2. Okay, where the phase is saturated vapor, where 100% liquid transform into saturated vapor, 100% vapor at state number 2. Okay, that's how we describe two different states for this question by using the schematic diagram and also by using the TV diagram. Okay, now we want to determine the volume change, which is in terms of symbol will be delta V, capital letter V, and data given is mass equal to 200 gram, and then we change into SI unit, also equal to 0.2 kilogram, and P constant during the process because it involves the saturated liquid water and also the the saturated vapor, which is involved with the boiling process or vaporization process, where during the process the pressure is constant and also the temperature is constant. And the value of P saturated is 100 kilopascal. Equation involve delta V equal to M delta V, delta specific volume, equal to mVg minus Vf. So we need to know the value of Vg and also the value of Vf at the specific state. Okay, for state number 1, so we need to solve state by state in terms of data. So for state number 1, we know that the phase is saturated liquid. So in order to get the data, so we need to refer to the saturated water table based on pressure. Okay, because the pressure already given, and from the table we can obtain directly the data. Okay, this is the saturated water table based on pressure. So at 100 kilopascal, the value of Vf at 100 kilopascal equal to 0.001043 meter cubic per kg, and Vg at 100 kilopascal equal to 1.694 meter cubic per kg. Okay, so from this value we can determine the volume change delta V, where delta V equal to M multiplied by Vg minus Vf. Okay, mass equal to 0.2 multiplied by 1.694 minus 0.001043. So we'll get I call the volume change is equal to 0.3386 meter cubic. Okay, done for the question A. B, energy transfer. So energy transfer actually refer to the delta H, the enthalpy difference. Okay, the enthalpy difference in kilojoule or joule. So we know that for delta H equal to mass multiplied by specific enthalpy. Okay, specific enthalpy delta H, specific enthalpy change delta H small letter, equal to M multiplied by Hg minus Hf. Or we can use this formula, which is also equal to M multiplied by Hfg. Okay, so the Hg value, Hf and also Hfg we can determine from the table. Okay, refer to the saturated water table based on pressure. So from this one also, from this table also, because we already have the pressure, the same pressure, we can determine directly the value of Hg, Hf and also Hfg. So from the table, Hf at 100 kPa equal to 417.46 kJ per kg, Hfg equal to 100 kPa equal to 2258.0 kJ per kg, and Hg value at 100 kPa equal to 2675.5 kJ per kg. So delta H equal to M Hg minus Hf. So substitute the value. So we'll get the value of delta H, energy transferred during the vaporization, is 451.61 kilojoule. However, if we use the second method or the second formula that involves Hfg, so delta H equal to 0.2 multiplied by 2258.0 kilojoule per kg, and we get the value is slightly different. So we have 451.60 kilojoule. So the value almost the same. Okay, almost the same by using both formulas. So you can choose any formula to determine the delta H, whether you want to use Hg minus Hf or you want to use directly Hfg, because for this table, the table provide Hfg. So in case in the table you don't have any Hfg formula, so Hfg actually same as Hg minus Hf. So we will get the same value in terms of Hfg. Okay, that's how we determine the solution for the example 3.3.